Hey guys, and welcome back to the Diving Squid YouTube channel. This is the second episode in my 2D procedural generation series, and in this episode we're going to look at how to make awesome overworld terrains with procedural generation and Perlin noise. If you haven't followed the short tutorial that was the first episode, make sure to check that out first, because in that you can download the ground tile package and open it up inside of Unity by double tapping it, which will allow you to import the ground files and tile set sheet, or you can design your own of course. Once you've followed the last tutorial, come back to this tutorial where we're going to open up the scene we made last game with our ground palette, ground tile set and rule tile. Now to start the tutorial, I'm going to create a new empty game object inside of the scene, and I'm going to call this procedural generation. On this, I'm going to add a new C# script and I'm going to call this procedural generation. Open this up inside of Visual Studio. To start our script off, I'm going to type using Unity engine.tilemaps. Then I'm going to declare all of our variables, and they're all going to be under serialized fields. So first of all, I'm going to create an integer called width and height, a float called smoothness, and then a float called seed. I'm also going to create a tile base, and I'm going to call this ground tile, and then I'm going to create a tile map, and I'm going to call this ground tile map. Lastly, create an integer and call it map. Inside of a start function, I'm going to call a function called generation, which we're just about to create. So inside this new generation function, I'm going to set our ground tile map to clear all the tiles because we want to start on a fresh canvas every time we generate a world. Then I'm going to set our map to generate array, which is another function we're about to create. And I'm also going to set map to terrain generation, which again we're about to create later in the video. Lastly, call a render map function, which we will also make. Now we're going to start making these. First of all, we're going to create the generate array, which we just typed above. Make sure you type it the exact same. And then we're going to pass through our width and height parameters. Inside of this, we're going to get our map and we're going to set it to a new integer with our width and height. Now we're going to create a couple of for loops for our x-axis and our y-axis on our map. So I'm going to create this one for the x, and then inside this I'm going to do one for y. Make sure you get the width and height correct. And then inside this I'm going to type map x and y equal to empty. And then we want to return our map, which we just made, outside of the for statement. Now I'm going to create the other two things that we called above. So first of all, I'm going to do our terrain generation so that we can actually generate our terrain. I'm going to pass in our map integer, and I'm also going to type int Perlin height, and then inside of a new for loop I'm going to set our Perlin height that we just created equal to mathf.round to int, and then mathf.perlin noise, x divided by smoothness and seed, and then all of this multiplied by our height divided by 2 so that we never get a whole number. Then we're going to set our Perlin height plus equal to height divided by 2. Now inside of another for statement, you can double tap the tab key to automatically make it. I'm going to set our map equal to 1. And also don't forget to return our map outside of the for statements. Lastly, to create the last thing we called, which was our render map, I'm going to create the render map function, and I'm going to pass in our map, our tile map, ground tile map, and our tile base, ground tile base. Inside of this, I'm going to create a for loop for both our x and our y-axis, and then inside these I'm going to create an if statement stating if our map is equal to 1, and then inside our if statement we're going to set our ground tile map dot set tile, then a new vector3 int, and I'm going to pass in our x and y and then our ground tile base. Our terrain is going to generate when we start the game because we've called our generation function in a start function. I want to generate the terrain every time I hit the space key just so that I can test out different shapes, but if you only want to generate one, then just leave out the update function. Back in our Unity scene, you'll see that we need to assign some values. So first of all, I'm going to create a new 2D tile map object called ground tile map, and I'm going to drag this inside of the ground tile map section. Now drag in our ground rule tile that we created in the last episode into the ground tile, and give it our width and height a value of 70 and 35. I'm going to give our smoothness something like 30, but make sure to play around with this. I'm going to drag my game window down here because my camera won't fit the entire thing, but you can rescale yours if you want. This is just for testing purposes. If I hit play, you'll see that an awesome terrain has been generated. Right now I have a smoothness value of 30. If you increase that value, you'll get a really smooth terrain, almost flat. But if you decrease it, you're going to get a really mountainous terrain, like this. Keep playing around with this to see how you like it. Another way to alter your terrain is to change the seed. You can do this manually, but I'd recommend creating a random seed inside of the script. This is covered in the next episode where we're also going to generate caves. I'm going to quickly change the scene a couple times and hit space to refresh our terrain, and you'll see that it creates unique and awesome landscapes. Right now, if you'd want to use this in a platformer game, for example, our player would actually fall straight through the ground. So to edit this, we're going to go into our ground tile map and add a tile map collider 2D. If I quickly draw on our tile map, you'll see that every tile now has a little green box around it, just like a box collider or something. So that's our problem solved. Obviously, if we're making caves, we're going to not have a tile map collider because we want our player to walk through the caves. That's all for this tutorial. Make sure to stay tuned for the next tutorial where we're going to actually generate the caves, similar to something like Terraria. Thank you so much for watching, guys, and thank you for all the support on the channel. It means so much. Also, a big thank you to my awesome patrons for the support this crazy year. If you'd like to check out my Patreon, the link will be in the description below. If you need any help, don't forget to check out the Discord server. Thanks for watching.